What's up guys, this is Massey. Welcome to another video. In this video I want to talk about integration by parts and show you how to use this method to solve integral questions. So when we're talking about integration by parts, we have integral of u dv. That's going to be equal to u times v subtract integral of v du. And on the second step we need to solve this integral. Let's see the first example. We have x times cosine x dx. So I'm going to consider u as x and dv as cosine dx. So du is going to be dx, v is going to be integral of dv or antiderivative. That's going to be sine x. So using the formula, I need to write u times v, which is x times sine x, subtract v du. V is sine x, du is dx. So that's going to be x sine x. And here we have negative cosine x plus c. So the answer is going to be x times sine x plus cosine x plus c. That's the final answer. Next example. Integral of ln x dx. I'm going to consider u as ln x, dv as dx. So du is going to be 1 over x dx. V is going to be x. So we have u times v, which is x ln x, minus v dx, which is x times v du, which is going to be x times 1 over x times dx. That's going to be x ln x minus dx. It's going to be x ln x minus x plus c. Next example. Arc sine x dx. I'm going to consider u as arc sine x and dv as dx. So du, the integral of the derivative of arc sine x is 1 over root 1 minus x squared dx, and v is x. So we have arc sine x dx is going to be u times v, which is going to be x times arc sine x minus v du. So x over square root of 1 minus x squared dx. So u is 1 minus x squared, du is negative 2x dx. So x dx is going to be negative du over 2. So we have x arc sine x minus negative du over 2 root u. That's going to be x arc sine x plus 1 over 2 u to the power of negative 1 over 2 dx. And then we have x arc sine x plus 1 over 2 times u to the power of negative 1 over 2 plus 1, negative 1 over 2 plus 1 plus c. So we have x arc sine x plus 1 over 2 u to the power 1 over 2, 1 over 2 plus c. This 1 over 2 and 1 over 2 cancels out, and we have x arc sine x plus root u plus c. So that's x arc sine x plus square root of u was 1 minus x squared plus c. That is the final answer. Next example. X to the power of 3 times ln x dx. This example I'm going to consider u as ln x, dv as x cubed dx. So du is going to be dx over x, v is going to be x to the power 4 over 4. So u times v is going to be 1 over 4 x to the power 4 ln x minus v du. So x to the power 4 over 4 times dx over x. So that's going to be 1 over 4 x to the power 4 ln x minus x to the power of 3 over 4. And when you do this integral, that's 4 in here. It's going to be 1 over 4 x to the power 4 ln x minus 1 over 4 times 1 over 5 x to the power 5 plus c, which is going to be equal to x to the power 4 ln x over 4 minus x to the power 5 over 20 plus c. Next example. X to the power of 6 times sine x dx. So I'm going to consider u as x to the power of 6 and dv as sine x dx. So du is 6x to the power of 5 dx. V is negative cosine x. So that's going to be u times v, which is negative x to the power of 6 cosine x minus v du, negative cosine x, 6x to the power of 5 dx. That's going to be negative x to the power of 6 cosine x. That's going to cancel out, and we have 6x to the power of 5 cosine x dx. Now I can write this 6 in here and have another integration by parts. So I'm going to have u to be x to the power of 5 and dv is going to be cosine x dx. So du is going to be 5x to the power of 4. V is going to be sine x and dx. So that's going to be u times v, x to the power of 5 sine x, minus v du sine x times 5x to the power of 4 dx. So that's going to be x to the power of 4 sine x minus 5x to the power of 4 sine x plus c. So as you see, you need to do basically keep repeating integration by parts. Next example, I'm going to have e to the power of x sine x dx. I'm going to have u as e to the power of x and dv sine x dx. So du is going to be e to the power of x dx. V is going to be negative cosine x. So u times v is going to be negative e to the power of x cosine x minus v du. Which is going to be negative e to the power of x cosine x plus integral of e to the power of x cosine x dx. So what I'm going to do, I'm going to have another integration by parts for this part. e to the power of x cosine x dx. I'm going to have u equals to e to the power of x. dv is cosine x dx. du is e to the power of x dx. v is going to be sine x. Remember, we are doing only this part. So v du, v times u is going to be e to the power of x sine x minus v du, which is e to the power of x sine x dx, which is going to be the original question. So I'm going to say e to the power of x sine x dx is going to be negative e to the power of x cosine x plus e to the power of x sine x minus e to the power of x sine x dx, which is the same as the original one. If you move it over there, it's going to be 2 e to the power of x sine x dx, e to the power of x sine x minus cosine x. So therefore, integral of e to the power of x sine x dx is going to be e to the power of x sine x minus cosine x divided by 2. Next example is going to be x e to the power of x dx. So u is x, dv is e to the power of x dx. So du is going to be dx, v is going to be e to the power of x. So u times v is going to be x e to the power of x minus v du, which is going to be e to the power of x dx. The integral of this one is going to be just e to the power of x. So x e to the power of x minus e to the power of x plus c. If you have x e to the power of 2x dx, what we will do? Again, we have u equals to x, dv is e to the power of 2x. So du is going to be dx, v is going to be 1 over 2 e to the power of 2x dx. U times v is going to be x times, or 1 over 2 times x times e to the power of 2x. There is no dx here. Minus v du, 1 over 2 e to the power of 2x dx. So that's going to be 1 over 2x e to the power of 2x minus 1 over 2 e to the power of 2x plus c. So that's going to be 1 over 2x e to the power of 2x minus 1 over 4 e to the power of 2x plus c. Next example. Theta, integral of theta, e to the power of theta plus pi d theta. If u is theta, dv is e theta plus pi d theta, du is going to be d theta, v is going to be e to the power of theta plus pi. So we have u times v, so theta times e to the power of theta plus pi, subtract v du, which is e to the power of theta plus pi times d theta. So with theta e to the power of theta plus pi minus e to the power of theta plus pi plus a constant number. So e to the power of theta plus pi, theta minus 1 plus c. Next one, x times cosine x dx. That's simple. U equals to x, dv equals to cosine x dx. So du is going to be dx, v is going to be sine x. So u times v, x times sine x, minus v du, which is going to be sine x dx. So x sine x minus negative cosine x plus c. That's going to be x times sine x plus cosine x plus c. Next example. Integral of x times square root of x plus 1 dx. So we can say u is root x plus 1, dv is going to be x dx, du is going to be 1 over 2 root x plus 1, v is going to be x squared over 2. So v times u is going to be x squared over 2 root x plus 1. Subtract v du. It's going to be 1 over 2 x squared times 2 root x plus 1 dx. So we have x squared root x plus 1 divided by 2 minus 1 over 4 x to the power of 2 over x plus 1 dx. Now what I can do, I can say, I'm going to use this part by substitution. I'm going to have u equals to, or we used u already, let's say m equals to x plus 1. So m minus 1 is x, and x squared is going to be m minus 1 squared. So we have m minus 1 squared over root m dm. So that's m squared minus 2m plus 1 over root m dm. So that's going to be m to the power of 3 over 2 dm minus 2 m to the power of 1 over 2 dm plus m to the power of negative 1 over 2 dm. That's going to be 5 over 2 divided by 5 over 2 minus 2 m to the power of 3 over 2, 3 over 2 plus m to the power of 1 over 2, 1 over 2 plus c. So then we can say we already had this part as well. So I'm going to say the answer to this question is going to be x squared root x plus 1 over 2 minus 1 over 4. M is x plus 1, so x plus 1 to the power of 5 over 2 divided by 5 over 2 minus 2 x plus 1 to the power of 3 over 2, 3 over 2 plus root x plus 1 divided by 1/2 plus a constant number. So that's going to be x squared root x plus 1 over 2 2 over 5 x plus 1 to the power of 5 over 2 plus 1 over 3 x plus 1 to the power of 3 over 2 negative 1 over 2 root x plus 1 plus a constant number. So that's going to be the final answer for this question. So these are the examples for integration by parts. I hope you enjoyed this video. Please leave me a comment if you have any question, and please don't forget to subscribe this channel. You can have access to many other videos regarding integration and other topics in calculus, algebra, chemistry, and physics. Thank you for watching and have a great day.